chapter 7, section 7.7. Here we are talking about the subject of complex number. You know, we understand that if you have a radical with the even root, you cannot have the negative numbers. So like if I have like -9, that would be undefined. Means we don't have the real number, but we could come up with the imaginary number. What it is, we are introducing a new term that I, which is a complex number, is equal to radical -1, or I to power of 2. When I raise this to power of 2, when you raise the radical to power, it would remove that is I2. So what we do for this one is, instead of radical 2 with a -9 under, we write it as radical 9 times square root of -1. Remember, we had a formula that if you have radical A times radical B is radical AB. You could also take the radical and break it into 2, like this. But this one, according to this definition, we replace it with I. So now radical 9, since this is positive, is 3I. So radical -9 is equal to 3I. It doesn't have a real number, but it has an imaginary value of 3 now. So we use that property to remove the negative from a radical with an even number. Like, what is radical -7? You write it as radical 7 times radical -1, or radical 7I. So as long as you understand that by removing the negative from the radical, you have to just put an I, we don't have to go through this process. Like, what is radical -16? So then all I need to do is, okay, I remove the negative out and put I here. So it would be 4I. What is radical -5? Remove the negative out and put the I here. Okay. So complex is the complex numbers is the vector, which is A plus BI. It has a real part and imaginary part. So this is the way we always write the complex number. It has a constant plus, you put a number here, a number times I. You see that as you go through the example. This is the way we always write it, A plus BI. Real part and imaginary part. All right. So here, radical -4, you remove the negative out, and you put the I here, see? And what is radical 4? 2. Radical -150, remove the negative out and write it as 150I, and then you just simplify 150, just show you here. If 150 is 5 to the power of 2 times 6, 5 is released from the radical, so that would be answer. 7 is outside of this radical. 7 has nothing to do with this radical, but I need to remove negative out. So it would be like 7 radical 28. Since you're removing that negative, you got to put an I here. Okay? And then the rest is just how to simplify 28, take the 2 out, stuff like that. Now, each of this radical, when you remove the negative, it would be an I here. Radical -17, you remove the negative out, you put the I here. And then when you multiply these two, Radical 10 times radical 17 is radical 70. Remember, radical A times radical B is you combine into 1. So radical 10 times radical 17 is radical 170. What is I times I? I2. Okay? And I2, we said I2 is -1. So I write it here that I is radical -1 and I to power of 2 is negative. So when I see I2 power of 2, I replace it with the -1. So that -1 comes to the front. So it will be -170. Same thing here. 16 doesn't have any negative under the radical. So radical 16 is 4. But this one itself is definition of I. When you see a radical -1, that's the I. So this is 4I. When you are dividing two radicals, you combine into one fractions according to the formula that we discussed before. So that would make it -24 divided by -2, which is 8. See, this one that has nothing to do with complex number because he already, when you divide, the minus is gone. So it would be just radical 8, and radical 8 is 2 radical 2. Now, subtraction and addition of complex number is very similar to like terms. Let's say I have something like this: 8 plus 7x minus 9 minus 6x. You remember when we were doing how to simplify the expressions like this? 8 plus 7x, and if you distribute negative 9 plus 6x, then you look for like terms. This 2 is -1, and this 2 is 13x. The same process works for a complex number. See, you do it like that first, and then you add all the I together, so like in like terms. Remember I said normally we write it as A plus BI. If you write it like this, it's correct, it's not wrong. But if you want to write it in the form, you always put the number first and then whatever number times I second. This is just the general way of writing it. But as I said, it's not wrong if you write the other way. This is multiplication. See, there is a sign of multiplication here. When you multiply, numbers always multiply separately. Remember, like when we have -8x and you multiply that by -2x, it would be -2 times -8 is 16. And what was x times x? x2. Same thing with the I. -8 times -2 is 16. I times I is I2, but we know I2 is always -1. We know I2 is -1 because I is radical -1. So anywhere you see a I2, replace it with a negative. Again, this is very similar to the polynomial. You know, when you have radical 6 plus 5x times radical 6 minus 5x, remember how you would distribute like that? Same thing here. The only difference is here, when you see an I2, change it to the -1. See, so first what I do is I distribute. These two cancel because they're equal. And then I2 is a -1. -1 times -25 is positive, so the answer is 31. Now, quotient, right? The quotient. You know, we had the sections of previous section, we're talking about rationalizing the denominator. When we had a problem like this and we asked you to rationalize the denominator, what would you do? Rationalizing denominator means that you don't want to have any radical at denominator, right? So we multiply this by radical x over radical x. So then this 2 is x and that. You don't have any radical at denominator. This is rationalizing. We do the same thing for complex number. See here you have 9 over I. You don't want to have any complex number at the denominator. So multiply this by I over I, which is 1, right? I over I. But at the bottom, you have I2, and I2 is -1. See? So you end up having -9, but you don't have it at denominator anymore. That's what you have here. You know, when we had something like this, let's say 1 over radical x plus radical y, how do I rationalize the denominator? Again, we had this on previous sections. How do we rationalize the denominator? How do I remove the radical? In this case, because it's not just one single radical, it's some. We always multiply by conjugate or the same one with the opposite sign. That's what we used to do. And then we write it as x minus y. See, you don't have a denominator. Or if you have something like this, I want to remove the radical. What would I do? I multiply both sides by 3 plus radical a, 3 plus radical a. Same thing with the opposite sign. So in that case, you had 9 minus a, see? And the top was 3 plus radical a. That's how we did the rationalization with the fractions. If you have more than one radical, we do the same thing here. See here? I have 9 plus 5i and 1 plus I. So what I do is, since this is 1 plus I and I want to remove I here, I multiply by 1 minus I. I'll put it here and there. And when you multiply, this is what you get. When you see I and minus I cancel. When you see I2, you put -1 here. See, 1 minus minus 1, which is positive 2. Okay, so this is what you get. Again, you try to write it as A plus BI. See, they even ask you here. Write the answer in this form. Let's put the number first and I after. Okay, very similar to rationalizing. You want to, so when you say write a quotient in this form, means you don't want to have I at the denominator. This is multiplication. Minus 7i times 6i. It's like, how do you multiply minus 7x times 6x? It would be minus 42, x to power of 2, right? Same thing here. 42 I2. Again, when you see I2, I2 is always -1. Multiplications. Very similar to polynomial. Look, 5x times 3x minus 4. You had before. Minus 5x times 3x. -5 times 3 is -15. X times x is x2. Negative 5x times negative 4. When I distribute is positive 20x. Instead of x, I use I. But just remember, I2 is negative 1. These are all very similar. So you distribute 4 and then 8i. Again, when you see I2, you substitute negative 1. I'll see here. You know, if this is positive, I figure I thought this is multiplication. So if you want this to be correct, let's just change it to multiplication. Okay, then you have a correct solution. Sorry about this. It was addition, but I thought it was a multiplication. It's hard to see it. That's why when you look at the addition, it's different. But if it is an addition, it's like this: 9 minus 8i. If it's a plus, then we don't really need the parentheses. It's just 9 minus 8i plus 4 plus 3i is 13 minus 5i. If it's positive. If it's multiplication, that's how you do it. Sorry about that. Okay. Same thing. You remember, you have an I at the denominator, right? You want to get it. You don't have to multiply by minus 8i minus 8i. If you do, it's okay. But since you're trying to just get rid of this I, just multiply by I over I. Again, you don't have to multiply by minus 8i or minus 8i. If you do, it's not wrong, but just more work for you. So if you just put I and I, minus 8i times I is minus 8i2. And then you distribute I here. I2 is negative 1. See, doing that, we got rid of I at the denominator. And again, you write it in the form of a plus bi. This is the form of a plus bi. When it's 9 plus I, you have to multiply by the negative sign or opposite sign. So in that case, you don't have at the denominator, you don't have number at the denominator, see? And since they ask us to write it in this form, that's what you have. So you multiply this first, and then these two cancel. I2 is negative 1. I'll show it to you here. Same thing. It's 2 plus I multiplied by 2 minus I. And I2 is negative 1. Anywhere you see I2, just replace it with negative 1. Multiplications, you distribute, you bring radical 2 and multiply, and then 3i. Okay. Now, but what about these ones? Number 20. What is I2? We know I2 is negative 1. What is I to power of 3? You could write this as I2 times I1, or just I. I2 is negative 1, so is negative 1i, or I3 actually is negative 1i, or just negative I. What is I to power of, let's say, 8? If it's even number, you write it as I2, and then the whole thing to power of 4. Remember, if you have more than one exponent, you always multiply the exponent. Very first formula that we use in this class. if you have more than one power, you always multiply it. So you could take 8 and write it as that. But we know I2 is -1. What is -1 to power of even number? -1 times -1 times -1 times -1 is 1. So I to power of 8 is 1. Okay. What about I to power of 12? Again, divided by 2. That is equal to I to power of 2, the whole thing to power of 6 again, right? So it would be -1 to power of 6, which is 1. What is I to power of 200? Divided by 2. See? It's -1 to power of even is always 1. You could use your calculator for that. What about I to power of 21, the odd number? You cannot divide it by 2, right? Okay, write it as I to power of 20 times I, and then work on this one. I20 is I2 to power of 10, or -1 to power of 10, or just 1, I or I. See? If it's an odd number, just take 1, subtract 1, and write it like that. Like what is I? No, let's just get something I to power of 45. Write it as I to power of 44 times I. 44 is divided by 2. -1 to power of even is 1. 1I or just I. See? So then, so if that's the case, then you have I40 is like that, and I43, look, I43 is an odd number, right? Write it as I42 and I, and I42 is that. Okay, so that would be end of chapter 7.